and welcome to Robert Morris University Math 0900. This is Brianne Pernick, and this is Chapter 5, Lessons 4 and 5. If you will note on your syllabus for this week, you are being tested on the content for Section 5, but not on the content for Section 4. I am going to teach you the content that's in Section 4 because you will be expected to know how to factor quadratics that are in the form of ax squared plus bx plus c for Math 1010. Whomever your professor is will likely pick up and have an expectation that you know how to factor this type of quadratic. So I do feel that I should teach this content to you. However, it will not be on a test or quiz. So we're going to go ahead and begin with the information from Section 5.4. When you have a quadratic that's in the form of ax squared plus bx plus c, this means that the coefficient of your x squared term will not be a positive 1. And you should remember from the last section that we did, which was Section 3, that I taught you the C method for factoring, which worked only when that coefficient was a positive 1. When the coefficient for your x squared term is not 1, you must use another method to factor. And the method that I teach is called the AC method. In the AC method, you must first multiply the two numbers that are in the position of A and C. Next, you will identify factors of AC that will add to the position of B. Whatever number is in the position of B, you want to make sure that they add to that. Once you find the correct combination of factors, we're going to split the B term apart using those factors. And then we will use the factoring by grouping method that we learned in Section 2. Let's take a look at an example. In example 1, you'll see that the leading coefficient is 2 for our x squared term. This means that we cannot simply use the C method, and we must use what I call the AC method. That's going to require us to multiply the numbers that are in the position of A and C. So we're going to multiply the 2 and the positive 3. We're still going to set up a t-chart to help us find factors. So we want numbers that are going to multiply to AC but add to B. So once we multiply AC, 2 times 3 makes 6. We want numbers that are going to add to positive 5. So we start with our list of factors. We have 1 and 6, that adds to 7. 2 and 3, that adds to 5. Okay, we found our factors. The next thing that we do, we bring down the quadratic term 2x squared, and we're going to split the B term into two terms according to the factors that we identified. So since we found positive 2 and positive 3, we're going to split 5x into 2x plus 3x. If we put them back together, 2 plus 3 is still equal to 5, so we have not changed that value. And then lastly, we bring down the positive 3, which was the number that's in the position of C. You will now note that you have 4 terms instead of 3. The only thing that we have done so far is split the 5 into 2 terms that are still equivalent to 5 if we were to combine like terms and put them back together. Instead, though, we're going to factor by grouping. So we're going to put two parentheses around the first two terms, and the last two terms. We now look for the GCF of 2x squared and 2x. We can factor out a 2x. 2x squared divided by 2x leaves me with x. 2x divided by 2x leaves me with positive 1. Looking at my second group, 3x plus 3, my GCF is positive 3. 3x divided by 3 is x. 3 divided by 3 is positive 1. I check to make sure that my group is the same. It is. So I'm going to drop it down into the next line, and I'm going to make a new group with everything that was left over. So my second group is 2x plus 3. That is the final answer to factoring using the AC method. Let's try example 2. Remember, our starting point is to multiply A times C. So we're going to multiply 4 times 3. So we want factors that will multiply to AC, which is 12. But we want them to add to the number that's in the position of B, which is negative 13. What kind of numbers will multiply to a positive 12, yet add to a negative 13? Well, if we use negative 1 and negative 12, that would add to negative 13. So those are the numbers that I will need to split my B term into. So we're going to bring down 4x squared minus 1x minus 12x plus 3. Remember, you take the terms that we just identified, the factors I should say that we just identified, and that B term is going to split into those factors. If we combine like terms, we get right back where we started. Now we're going to factor by grouping. So we're going to put parentheses around the first two and the last two, and we're going to remove the GCFs. The GCF of 4x squared minus x is x, so we'll go ahead and factor that out. 4x squared divided by x leaves us with 4x. Negative x divided by x leaves me with negative 1. Now remember, you want to achieve the exact same group. Pay attention to your signs. You have a negative 12x and a positive 3. In our group, we have a positive x term and a negative constant term. Remember what that requires us to do here. We have to flip those signs inside this quantity. So we will take out a negative of whatever that GCF is. We can take out a 3. So we'll take out a negative 3. Negative 12x divided by negative 3 will leave us with 4x. Positive 3 divided by negative 3 leaves us with negative 1. Did our quantities turn out the same? They did. So we're going to drop that quantity down, and we will make a second quantity with everything that was remaining, which is x minus 3. And there's our final answer. I would like you to go ahead and try example 4. Please remember, set up that T-chart, use your signs, and then utilize the factoring by grouping. Please pause the recording and then check your answer as soon as you're ready. Okay, at this point you should be ready to check your answer with me. The first thing that you should have done is multiplied A and C, which are the numbers 2 and 3. So we're going to set up our T-chart. to show that we want to multiply to AC. So when we did that, we had 6. But we want to add to B, which is positive 5. So we have the numbers 2 and 3. I apologize, everyone. This is exactly the same problem that was in number 1. Your book tries to show, and I apologize for forgetting this, tries to show 2 different ways to factor this. Their first way that they attempt to show it is a guess and check, which takes an extremely long amount of time. I don't teach that way because it's ineffective. I go straight to using the AC method. So for example 4, it's exactly the same as example 1, and you should have done these exact same steps that we did if you worked this problem out and didn't realize that it was the same. Example 5 is the same as example 2. Again, they wanted to use guess and check for the first 2 and then the AC method for the second 2. So we're going to go ahead and skip down to the second section here, which requires us to factor out a common factor or a GCF before we start. Now, as I mentioned, looking for a GCF is always going to be the very first thing that you want to do before you start a problem. It makes your numbers smaller and more manageable whenever you can divide out that GCF. So for example 7, we're going to jump right there. We have that as we look at all 3 of those terms, all 3 of them are divisible by a 3. So we're going to go ahead and factor out that GCF of 3 before we do anything. 9 divided by 3 will leave us with 3x squared. 3x divided by 3 is going to leave us with just x. And negative 30 divided by 3 is going to leave us with 10. So now as you're looking at that quadratic, the numbers are smaller, but we still are going to have to use the AC method to solve this. We want numbers that are going to multiply to AC but add to B. When we multiply our A and our C, which are 3 and negative 10, we're going to get negative 30. And we want to add to B, which is the number that's in the position right here in front of X, which is 1. So we want a positive 1. I would like you to go ahead and finish this problem for me. And your 3 out front is just going to keep on coming down for the ride all the way to the end. Don't worry about it. Just keep it down in front of your parentheses. It's just going to be part of our answer. Go ahead and pause the recording. As soon as you're ready, hit play and we'll check your answer. Okay, at this point you should have had an opportunity to identify the factors that multiplied to negative 30 but added to positive 1. You should have found that negative 5 and positive 6 added to negative 1 but multiplied to our negative 30. Those are the factors that we're going to use here. So we're going to bring the 3 on down to the next line, bring down the quadratic term of 3x squared, and our x term needs to split up according to the factors that we identified. Now remember that we're going to be using factoring by grouping, so we want to make groups that are going to be compatible. I'm going to write my positive 6x first and my minus 5x second. The reason I did that is that I feel that 6 goes nicely with 3, and I feel like the negative 5 goes nicely with the negative 10. I can do that. okay? So 6x minus 5x gets me right back where I started there at positive 1x. So just to do a little check there to make sure that my math is still accurate. And now I'm going to slap some parentheses around my first two terms and my last two terms. And we're ready to start taking out the GCF of my first group. I'm introducing a bracket here just to show some separation because I am going to be using parentheses and I want to ensure that I don't confuse my terms together. So the GCF of 3x squared and 6x is going to be 3x. Factoring out that 3x, I'm left with x plus 2. For my next group, I have negative 5x and negative 10. The first thing that I see is that I need to take out a negative to flip my signs, and then the GCF is 2, so I'll be taking out a negative 2. I mean, not a 2, I'm sorry, a 5. Getting ahead of myself. So I'll be taking out a 5. Negative 5x divided by negative 5 leaves me with positive x. Negative 10 divided by negative 5 leaves me with positive 2. Close my parenthesis, and I'm going to close my bracket. Now I'm ready to bring down my 3. I'm ready to bring down my group that was identical, and I'm ready to bring down everything that was remaining in there, which was the 3x minus 5. And that, my friends, is the final answer for the factoring of this quadratic. As I mentioned, the AC method is not something that you are going to be tested on in this section, but I do want you to know how to do this because you will have to know this for Math 1010. If you have questions on this or if you want more practice, please feel free to contact me. I'll be more than happy to go over this with you. We're now going to move on to section 5.5, which you will be tested on, and this is special cases of factoring. We're going to specifically focus on the differences of two squares and perfect square trinomials. The difference of two squares is a special type of factoring because you'll notice that the first term is a perfect square. 9x squared is a perfect square, and the second term is a perfect square. 1 is a perfect square. We can take the square root of both of those terms and we would get an answer. So when you have a perfect square for your first term, a perfect square for your last term, and they're being subtracted, that is what constitutes the difference of two squares. And taking the square root, factoring these is actually pretty simple. You're going to take the square root of your first term, so 9x squared, taking the square root of that becomes 3x. So we put that in the front of our parentheses. We take the square root of the second term, which is 1, and then one of our groups gets a plus sign and one of our groups gets a minus sign. If you FOIL that and put it back together, you would notice that your middle terms will always cancel each other out, which is how we end up with the appearance of the difference of two squares to begin with. So there's our final answer right there. Let's try another one together. We have 25x squared minus 16. Both terms are perfect squares and they're being subtracted. Why don't you go ahead and set this up? Factor it for me using the rule I just taught you, and as soon as you're ready, press play and we'll check your answer. Okay, at this point, you should have taken the square root, you should have taken the square root of both the first and last terms. So 25x squared becomes 5x. So we put that in the front of each parenthesis. The square root of 16 is 4, and we're going to put that in the back of each parenthesis. One group gets a plus, one group gets a minus, and we are done. Again, it's always a good idea for you to check your work by foiling to make sure that you get back to where you started. I would like for you to go ahead and try example 3. Please pause the recording, try it out, and when you're ready, please press play and we'll go over your answer together. Okay, by now you should have had an opportunity to do example 3. This is a difference of squares as well. Both the first and second term are both perfect squares and they are being subtracted. So we're going to go ahead and take the difference of squares. The square root of 4x squared is 2x, so we write that in the front. The square root of 49y squared is 7y, so we're going to write that in the end. One group gets a plus, one group gets a minus. The next topic that we're going to cover is factoring perfect square trinomials. Sometimes before you jump into using the C method or the AC method, you can check to see if your quadratic expression is a perfect square trinomial. If it is, you can completely avoid having to find factors of this that multiply to that and add to this, because we can use the perfect square trinomial rule. And what you check for here is your first term a perfect square? If it is, great. Move on and check the last term. Is that a perfect square? If it is, good. You have one more test to do. You take the square root of your first term, and let's look at example 5 here. The square root of the first term's coefficient is 1. The square root of the second term's coefficient is 3. So we're going to do 1 times 3 gives us 3. And then we double that and get 6. If we end up with the value of b, when you do the square root of the first, the square root of the last, multiplied together and doubled, then you have yourself a perfect square trinomial. So that means that you can write a quantity squared. You take the square root of the first term, which is x, the square root of the last term, which is 3, and the sign of the term in the middle, which is a positive. And we're done. Let's try example 6. Is our first term a perfect square? 4x squared is. Is our last term a perfect square? 25 is. So next, we're going to take the square root of 4x squared and get 2x. And the square root of 25, which is 5, we multiply those to get 10, and then double it to get 20x. If we got the term in the middle, then we know that it's a perfect square trinomial. So we're going to set up a quantity squared. We take the square root of the first, which was 2x, the square root of the last, which was 5, and the sign of the middle. And that's our final answer. I would like for you guys to go ahead and try examples A and B. Please pause the recording, try the examples, and as soon as you're ready, we can go ahead and press play and go over the answers together. Okay, at this point you should have had an opportunity to complete both examples A and B. And what we want to do here is check to see if these are perfect square trinomials. Is 49x squared a perfect square? It is. How about 9y squared? It is. If we take the square root of 49x squared, we get 7x. And multiply that by the square root of 9y squared, we get 3y. So that's 21xy. If we double that, we get 42xy, which is our middle term. So that means we have a perfect square trinomial. So we can just write quantity squared. We take the square root of the first term, which is 7x, the square root of the last term, which is 3y, and the sign of the middle, which is a plus sign. And there's our final answer. Example B, 36x to the fourth. Is that a perfect square? Sure is. Positive 1. Is that a perfect square? Sure is. If we take the square root of 36x squared, or excuse me, x to the fourth, we would get 6x squared times the square root of 1, which is 1. So then we'll have 6x squared doubled, and we get 12x squared, another perfect square trinomial. So we're allowed to have a quantity squared. The square root of the first is 6x squared, the square root of the last is 1, and the sign in the middle is negative. The next examples show us, or I should say remind us, of the importance of factoring out any common factors before we start. As we look at this binomial, it's not a difference of squares. It's not a quadratic that we can use the C method or the AC method on, but you should notice that it has a GCF of 12. So we're going to go ahead and factor out that GCF of 12 right now, and that leaves me with x squared minus 4. When we put that back up there real quick, when we factored out that GCF, look at the quantity that was created. X squared is a perfect square, 4 is a perfect square, and they're being subtracted. That means that that is a difference of squares, which can be factored further. We take the square root of the first term, the square root of the last term, one quantity gets a plus, and one quantity gets a minus. If we had not factored out that GCF to start, we would never have seen that. That was a perfect square hidden underneath that 12. I would like for you to go ahead and try example 10. Start by factoring out that GCF and see what you come up with. At this point, you should have identified that the GCF of that expression was 6. So you should have started by factoring a 6 out of everything. 24 divided by 6 leaves us with 4x squared. 72 divided by 6 leaves us with 12x. And 54 divided by 6 leaves me with 9. As you're looking at that expression, you may think, oh, I need to do AC method, which would work. You would get there, but it's the long way because 4x squared is a perfect square. Its square root is 4x. 9 is a perfect square. Its square root is 3. 4x times 3 is 12x, and when we double that, we get 24x. Oh, I see my mistake right here. 4x squared's square root is 2x, right there. 2 times 3 is 6x times 2 is 12x. My apologies. Okay, so that means that this is a perfect square trinomial. So we can bring down our original GCF and write quantity squared. The square root of 4x squared is 2x. The square root of 9 was 3. The sign in the middle is a minus. So we don't have to go through and do the AC method and then factor by grouping. We can just run the little test on the side, as we have just done, and utilize the perfect square trinomial. The last concept that we're going to work on here is determining whether or not a polynomial is prime. And what that means is that sometimes polynomials cannot be factored at all. That means that there are no factors that expression, that quadratic, can be broken into. For example, part A, we have x squared plus 6x plus 12. It's not a perfect square trinomial. The coefficient of x squared is 1, so we would think to ourselves, okay, I need to use the C method. I want factors I apologize for continuing to write over top of my graphic and moving it around. We want factors of 12 that are going to add to 6. So I have 1 and 12. I have 2 and 6 is 8. I have 3 and 4, which is 7. As you can see, there was no way that we could multiply to a positive 12 but add to a positive 6. It's not possible. There's absolutely no way for us to factor letter A. That means that letter A is prime. It has no factors. Letter B, we look at this in the beginning and think, ooh, this looks like it's some type of perfect square thing. 25x squared is a perfect square. 4 is a perfect square, but they're being added. We don't have a rule for perfect squares that are being added. We only have a rule for perfect squares that are being subtracted. Can't use that. So our next thought should be, well, is there a GCF? There's no GCF. There's nothing that you can do with that. So it also is prime. So those are just some examples of problems that you can do nothing with. And when that's the case, you write the word prime. That is your answer for a problem like that. As always, if you have any questions about anything that we covered in these two sections, please feel free to contact me. I am always here to help. Thank you.